Hi, welcome to the MD5 webinar. I will give another couple seconds for people to join, but we'll be starting shortly. Okay, welcome. I'm happy that you joined our webinar. It has been a while since our last one, but this time we thought we will do a special webinar. Usually we have external speakers from different partners and customers. This time we're going to concentrate again a little bit more on ourselves, and we're going to show you a nice new integration that we have launched recently that enables your support teams to integrate connectivity data in Azure. And for that, I will be presenting the first part. My name is Christian, and I'm the head of product at MD5. And also joining is Brian Smith, our technical writer, who will show you live how the integration looks like, how it's working, and the whole click through and a real demo, so that you see how the integration and the product looks like. So at first, how do I move the slides? There we go. At first, a little bit background about our webinar series. So I think this is probably something around the 15th webinar that we have been running in the past since the Corona outbreak. And usually we have, as I said, partners around the industry talking about specific areas of an IoT solution. For example, we had SAFT as a battery provider, or AWS that is a cloud technology provider, a lot of other different partners. So all the aspects that people need to build an IoT solution. If you have ideas for other topics, other partners that you may want to have invited, we're happy to take your suggestions. And maybe just one outlook, because I actually forgot the slide to put it in. We have another webinar, for example, scheduled now on the 3rd of December with Teltonika. With Teltonika, the router IoT gateways, and you will be getting the invitation, of course, after the webinar as well. So for today, as you can see, we have changed a little bit our CI, or corporate identity and brand, but here this goes more back to my sketchboard, how my little kids would maybe draw. Not a polished slide, but I just wanted to show a very simple problem statement, right? What is it? What you experience? So if you build an IoT solution and you want to connect your device with your application to send the data, you of course have, let's say, a tremendous choice for connectivity solutions, where cellular is probably one of the dominants, especially in mobile use cases, or in cases where you want to get directly connected without integrating in any infrastructure. And it's by far, I would say, the most reliable connectivity. But even considering that it's most reliable, if you have hundreds or thousands of devices, there are things happening, right? So because your devices are deployed in multiple networks, countries, have different firmware, have different modules, so something will happen. That is for sure. And then it's always the question, okay, the device, the data does not arrive at the application. So what's happening? Is it a device? Is it a connectivity issue? Is it an application issue? If it's connectivity, what is it, right? And so that is usually how your support team will see it, right? They will only see the application data, and that's it. Yeah, so they don't see anything downstream from device or connectivity. So to make this cellular connectivity or the connectivity aspects, you have to understand a little bit more on how cellular connectivity works. So before the device actually talks to the application, there is a lot of communication already happening with the mobile core network or here with our MNIFI communication platform. So there's signaling traffic. The device checks, can I even attach to the network? Do I have enough volume? Am I allowed to send data, or have I already used up my volume limit? Is in that area roaming allowed or not? Right, and all these things are pretty much invisible for anyone, right? So if there's no connection from the device to the application, there's no way that the application or your support team will ever notice. So the first way how we make this visible, all this setup communication, is in our portal. Yeah, so the MNIFI portal shows you in real time all the events that are necessary to troubleshoot connectivity. Yeah, as I said, for example, if your SIM card is not activated, yeah, then this would be showing up. Or if your volume limit is reached, then the portal would show you that you need to lift the volume or take other measures to solve the connectivity issues. And it's not only about connectivity issues, right? So usually your support teams or the people that are operating your solution, they have different parts of the solution. Yeah, as I was just saying before, right? So you have these different parts. You may even have portals for your for the hardware itself, where you track firmwares. You have your application. You have maybe even something for your batteries. So you have all the different data sources and for the infrastructure, and then you have to somehow get, let's say, the issues in one view, so that your support team understands, okay, this is now a battery issue. The ideal solution is of course to have single dashboards, to have everything integrated in one solution. And here we provide the visibility on the connectivity data via a real-time data streamer. And today we're going to talk about the Azure integration. Now, let me just give you one slide about the, oh, that is broken up. That didn't look like this in the first one, the preview. The connectivity metadata that we deliver through the data streamer is delivered not only to Azure, but also other cloud services. We have launched also Google integration, which we will have another webinar on later on. On AWS, we already had, I think a month ago, a webinar together with AWS. And we have also integration in other third-party cloud services, Device Pilot, Keen.io, Datadog, Salesforce, and Automate.io, and are looking actually here for other services where we see value that our customers are integrating different data sources into to display the data. So connectivity metadata, what is it? So what do we deliver in this data streamer? So a lot of the things are around network events, which are, say, from a naming perspective, might be technical, like PDP contacts and EMI change and the signaling or update location. But the end, to translate that, let's say in simple terms, network events, they show you if the device is online or if it just went offline, to which radio type, 2G, 3G, 4G it is just currently attached to, the cell ID. So the cell ID we deliver for certain technologies, for 2G. So then you have an approximate location of the device. Then the EMI change indicates if the SIM was taken out of the device and was put into a different device, or you get basically all these data path success or errors. Yeah, so if the data connection was correctly established, or if there was a failure, right? And success, if there would be only success, then I guess the things would not make much sense, because then the support teams would not do anything, right? So would be perfect, but as said, if you have, let's say, a complex setup, something is always happening. So your teams especially need the analysis of the errors. Yeah, but also you can, let's say, based on the network events, even do business reports to see where are your devices online, yeah, or how does your business grow over time. For that, also the usage data is very valuable. So the usage data just tells you per device or per SIM card the volume of service that is used, so the data megabytes and the SMS, the related costs, the network in which the data was consumed, and also the country. And then you can do, for example, analysis, very simple analysis, which Brian is going to show, which are, for example, devices that may have bad firmware and are generating a lot more traffic than other devices. Other information that we deliver are management events, so SIM activation and deactivation. So when does the SIM contract start and when was it deactivated? So that it gives you an overview of how many SIMs are actually live and how much you're paying for. But also user events, so someone logged in and had issues there. And if you're building your own custom connectivity model on it. So if you want to, for example, give your customers the possibilities to build their own top-up model, yeah, where they sell their device with, let's say, 10 euros included, and once this connectivity is used up, that they need to top up. You see also how this quota and prepaid limits, how these are reached and how these are managed. So so that's the content of the data streamer that we deliver to all these different cloud services. And today we're going to talk about Azure. And just to give a rough overview about Azure, so Azure is not only about giving you a virtual machine, but Azure has these very powerful services that basically already give you a managed service for certain aspects of your IoT solution. So building an IoT solution becomes just way more simpler if you, let's say, can easily connect the different services. So there is not a straight line connection from the device to let's say to the device to IoT hubs. That's usually the straightforward integration, right? So when you would design a solution now, it would probably go that way. IoT hubs is the entry point where devices can be authenticated and securely connect to the Azure services. But also customers are using their own implementation of the, let's say, for example, an MQTT broker, and have that within a virtual machine. So basically, when, for example, a customer does a lift and shift when they first have had an on-premise deployment and now are moving to Azure. And so after, let's say, this ingress, there's, let's say, several services that are available in the IoT space. So Event Hubs, that is where we're integrating our data streamer. Stream analytics for event processing, storage, different types, blob storage and the Cosmos DB, and also different business and operation functions. So Azure Functions, which gives you, let's say, the possibility to create APIs or to call APIs, and notification hubs to have an alerting. For example, if you detect that the device has an issue, you could send a notification via a short message to your operations team. And then there are also visualization tools available, Microsoft Power BI and time series insights. And for today, we're going to talk about this integration, so Event Hubs. We're using Event Hubs, Stream Analytics, and Power BI. We have this demo also documented in a guide on our website. And Brian is basically going to walk through with you and answer the questions that you have. There's also the possibility to use the blob storage to get increased retention. So this demo is, I think, for 1 or 7 days. But if you need more data retention, that would be, for example, through blob storage. Other integrations that we have is one is the managed VPN. So the integration from the device to the any IoT stack to a virtual machine, where basically the devices and the application go into a private network, and with that you can get remote access to the device, and the device is able to send data to the application without using a carrier-grade NAT. So device to device communication is more simplified. There's also this guide available on our website, but not part of today. That would be just too long. And we have also a time series insights, just a simple guide showing how the data streamer data would be visualized in Azure time series insights. So we're not conclusive in all of the services, but we will extend our guides, let's say, showing more use cases in the Azure IoT ecosystem. Okay, and with that, I will hand over to Brian, who will do the workshop and show really the demo how the integration works.
Yeah, thanks a lot, Christian. So as Christian mentioned, I'm the technical writer at Emnify. So I have the pleasure of documenting how a lot of the features work for customers, and also coming up with some nice proof of concept applications for a lot of the nice features that we have. So of course, what we have been, let me just share my screen. There we go. What we've developed over the last few months is this nice Azure Event Hubs integration. And that's what we're going to take a look at today, which is how to set one up from scratch. So on the left-hand side here, I have the Emnify UI. And this page itself is visible by this link icon, which brings you to application tokens, and also this panel here where you can manage data streams. I already have a few that are running at the moment, which can be inspected to see the status of the stream and give you an idea of what the destination is. And for today, I'll set up a new one and show the steps that are involved there. So before I actually create a stream here, I actually need to make one in Azure. So this is my demo account in Azure. So the first step that we need to do is create an event hub. The way these event hubs are actually grouped is by namespace. So it's possible to have several under this Emnify webinar namespace. For today's purpose, I'll just create a new one from scratch to show you what this flow looks like. So you can select a resource group, and we'll give this a new namespace name. Give it something like demo Emnify webinar. And for the pricing tier, this gives you the option to decide how many consumer groups will be provided to the actual namespace, and this is a matter of how many different consumers can actually be attached onto this event hubs within this namespace. So for testing purposes, this standard tier or this basic tier is fine, but this might need to be evaluated depending on your use case. So for testing, I found that most of these default values are perfectly fine. There's a validation step that makes sure that the naming of the namespace is correct, and we can click create. And at this point, the deployment starts. So this usually takes around 15 seconds or so before this namespace is created. But it's the only step in getting the integration going that requires a bit of time to take, so that's not such a bad case. And the convenient thing about creating resources in Azure is that you typically get some notifications when the deployment has been successful, which will then take you to the resource itself. So this is also quite good for monitoring the status of this. Okay, so that's done. We can click this go to resource link. And now we find ourselves in the namespace. So this isn't the event hub itself, but this is where you organize the event hubs. So this demo Emnify webinar namespace can have multiple event hubs. So we'll go ahead and create a new one. And we'll just give it the name demo webinar. Partition count is also related to how many consumers this event hub has. For the purpose of testing, if you have depends on how many events are coming through this event hub, but I've typically not had any trouble with just using one partition count. Depending on the activity or the number of events going through, this might need to be changed, but I haven't had any issues with that. Message retention is fairly important one, so there's a minimum of 1 and you can have a maximum of 7 days, and that's how long events will stay within the event hub itself. As Christian mentioned about the capture feature, this is something that you would want to do if the destination that the output of the events from Event Hub, if you change the destination from your let's say the stream analytics job, but if the data set gets deleted, then you've lost all events previous to this time period of the event hub. So it might be a good idea to stick on capture there, because depending on how it goes with experimenting, the setup that you have might change, and it's a good idea to make sure that you have this backed up. So for this purposes, I'll leave capture off, and I'll leave the message retention to the 7 days. Okay. So now that that's finished, we find the Event Hub itself under this Entities tab. And we can see it has a status of active. So in order to stream some events into this Event Hub, what we need to do is to create a shared access policy. So we click Add here, give the policy a name. We'll just give it the name Data Stream. And it needs manage permissions, and we can click Create. So once this is created, then we have a connection string primary key, which you can copy to the clipboard, and the setup of the Event Hub then is done. So we can switch back to the Emnify UI, click Add New Data Stream, select the Event Hubs, and paste in the connection string. So there's two options that you can use, the three options here. So you can stream either usage data, which is like traffic logs, as Christian mentioned, events, which is also platform events, or you can stream both. So depending on your use case, it might make sense to have these both separated into two different event hubs. But for our use case, we'll stream both, and we can filter out the ones that we want from our stream analytics job. It's also possible to stream specific events by filtering. So I can pick, if I just want to create PDP context events, I can also filter here. But at the moment, I'll just select streaming all events. We can click create, and it's already set up and running. So if there's an error there, this label will show either a pending notification or a state if the status is not known, or it will show running if there's if your credentials are set up correctly and the event hub is found. If not, you'll see a warning message here, and some debug information will be printed below it. So if I switch back to Azure now, I can have a look at this event hub. And in this overview panel, which you find on the top left, we can see some events are already starting to come in. So we've had 7 events. Okay, so there's some data that's been successfully sent through. So how do I have a look at that? There's a very quick way to query what events are in there. That's through this process data tab on the left. So if we click explore, you have a default query here that just selects everything from some output alias, which we don't use here, but from the event hub. We can run test. I need to create permissions. And this will also take a second, but here we can see some of the events are already streamed through. Okay, so the next step to actually doing something with this is to create a stream analytics job. So if we go to analytics, stream analytics job, I've already created 2 here, but we'll create 1 more. So we'll give this a name. Resource group, you can pick a location. And we will leave this as West Europe. And I found that there's been no issue using the minimum number of streaming units here as well, with the amount of data that I've been streaming through. This is typically quite quick to create the stream analytics job, and we can take a look at what's happening. So here again, the main part to take a look at is this inputs section, the query, which is what will actually be running on the data, and the output. So for our input, that's where we can specify the event hub. And here there's a drop down already for this type of integration, and we can give this any name that we like. We can just give it the name Event Hub, because that will make a bit more sense when we're making a query. We can pick the Event Hub namespace, the Event Hub name, and we can also leave this to create as the default here, to create a new consumer group with the correct permissions to read from the Event Hub, and we don't need to partition by anything, and leave the rest of the default values. So once this is finished creating an input, it will check if it has permissions. And if all is well, then we can read data from the Event Hub. And it looks like a success. And now we can specify an output. So for our case, what we want to do is use PowerBI. And 1 second, let me just authorize this. So this is necessary to make sure that the account that you're using has permissions to actually stream to create a table and a data set within Power BI. So I'll just put my credentials in here. Okay. So we'll give this an output alias of Power BI, and we'll pick a workspace within Power BI. Here we can give a dataset name of new dataset and a table called MNIFY data. The authentication mode is user token after you've given Azure permissions to write to Power BI, and then this will test the connection to make sure that you have permissions there. Okay, so the most important part here is the query section. The query itself that we've prepared for this is also available on the integration guide that we've published on our website. So you can copy this directly. And this should give you the fields that we're interested in for graphing some data. Okay, so you want to paste this in. You can save this query. And in the overview, then you can start this job. So what that will do now is run this SQL query on incoming data as it arrives and start to populate a new table within Power BI with the fields that we are interested in. And that will give us then the opportunity to make some nice reports and visualization based on the metrics that we're interested in. So here, this was something that I was preparing with this pipeline. This report has 4 pages to it, and the first one is very basically visualizing which devices are using how much data. You can identify them by ID. The second page of this report is a breakdown of which devices have been using each operator and which devices are the most active. So if you have a handful of devices, it might not be so clear to try and find the metrics that you're interested in here. So it's a very useful feature of Power BI that you're able to pick the top 3 or to filter by the top n number of devices. Most commonly, what you will be doing is creating time series analytics. And here is a nice example of graphing the data consumption of the devices over time from the data that we've been delivering to Power BI. And then, as Christian mentioned, one of the gaps that typically operations teams or engineering will have is network errors within reports. And here, what we're able to do, thanks to this pipeline, is create a very quick report that shows events that are warning types. So we can filter now on Power BI by the severity of the events that are coming through. And on this table here, we have a breakdown of the most recent warning events by endpoint ID. So this will be useful to troubleshoot to troubleshoot device connectivity issues and to be able to isolate that in terms of the performance of your IoT application. Okay. So those were the main features there. That's the bones of the actual pipeline. For monitoring how this job is working, it works the same way as the Event Hub itself. You can have a look at the input and output events, whether this is successful here in this stream analytics job. So this can be monitored the same way. So one of the strong points of stream analytics, which I think would be very useful in our use case, is anomaly detection. And the stream analytics library has a few built-in functions that are quite interesting to use. And this is the anomaly detection functions. So you don't have to write any specific applications for this. We can plug this directly into a sample of our the fields that we're interested in. In our case, we can pick the total volume, and we can run anomaly detection functions over that. And where this is useful is I don't have to specify what a specific minimum or maximum volume is. This function will run over all values and will mark outliers as being abnormally high or abnormally low. And this one is also something that we will share on the integration guide here. This can be plugged in the exact same way as the standard report here. And I've just made a small table that shows some outliers, which these are typically 10 times the average data consumption per device. So without having to invest too much time into defining what the expected values of the data consumption of your devices are, you can use some of the built-in tools in Stream Analytics to get some interesting troubleshooting insights for your IoT application. Okay.
Okay, Brian, I guess that was the presentation, right?
Yes.
Okay, thanks. Thanks, that was really great to see this in action. So we wanted to give a little bit of a chance that you can ask questions. Of course, it's not like the usual technology training or background, but still, there is the question menu in GoToWebinar. Please let us know if you have any questions, and we're happy to answer them.
Yeah, while we're waiting for some people to write some questions in there, if anyone has any questions, one of the nice features of Power BI here is that I can export some of these graphs directly within Teams. So if your operations teams are already using Microsoft Teams to coordinate or triage or for troubleshooting, this would be the nice integration for being able to share specific dashboards that show potential issues. So if you click this Share in Teams button on one of the messages, then you have a link generated directly to the dashboard that can be shared with operations or engineering for quickly troubleshooting. For instance, here we have a lot of device issues that I created by setting a service limit here. So the device couldn't access the network, and here we have a lot of warning events. And this would typically, like Christian mentioned, be platform events that wouldn't be normally available to an application.
Brian, here's a question from the group. Is it also possible to get the I'm trying, it's a little complicated written, but let's say the relative data. Yeah? So if you have one day specific volume and the next day high, so relative alerts.
Yeah.
Is that possible?
Yeah, thanks. Yes, it is. So this is one of the features of this anomaly detection function, is that it actually works over a sliding time window. So using this stream analytics, depending on how you would craft this query, then you would sample relative to the previous day or to the previous hour or to whatever time frame that you want. So you could say that I want to insert a record where the previous hour was more or less than the current hour. And this is quite flexible. Of course, there's a ton of different use cases for different kinds of analytics and different queries that you can run here. And depending on the insights that you're interested in, and if you have a good idea of which metrics that you think would be really critical to report on, then that can easily be added within the stream analytics job. And one thing to note is that also I have multiple stream analytics jobs running over one event hub. So there's also plenty of room to have one stream analytics job working with that's populating one data set in Power BI, and to create multiple other stream analytics jobs that create different tables with different insights that you want. So
I have here another question. Is it necessary to use Azure IoT for that integration? I think that I actually answered in the beginning. So basically, the Azure IoT, there's usually two models that you integrate in Azure. Either you do your own MQTT broker or your own application server that is running on a virtual machine, or you use the Azure IoT Hub. For us, if the data streamer is using the Event Hubs integration, so it's kind of independent, but the Event Hubs is usually also what you would use if you use Azure IoT and then want to run analytics on top of it. So yes, you can use it with Azure IoT and also with the VM version. Okay, I think that these were the questions. Then thank you everyone for joining. It's already getting quite dark here in Berlin. Winter is coming. Looking forward to the next webinar with Teutonica, and we will send out the recording and the slides after the webinar. Will take 1 or 2 days, so you will get the information. Brian, thanks for the presentation. It was great to see it live.
Thank you very much. Yeah.
And
no problem.
Talk to you soon.
Thanks a lot.
Bye-bye.
Bye-bye.